So take a look at the warm-up, find the scale factor, find the missing sides, but make sure you're paying attention to corresponding sides, because the order of the similarity statement is going to tell you which sides correspond with each other so you don't accidentally set up the wrong proportion, and this will greatly help you on today's quiz. Awesome job, Eric. The scale factor is 5/3. Scale factor is second over first, and we need to find two sides that go together, two sides that correspond. So we take a look at one of them. Let's just look at ON. ON is listed third and fourth. What else is listed third and fourth? Well, JK. So we put ON over JK, and that reduces to 5/3. So to find your missing sides, you can now use your scale factor, or you can use a proportion. We're looking for HI. I would recommend calling it a variable, call it X. And we're looking for MN. I would recommend to call it Y. So, as I said, you can set up a proportion or use scale factor. All right, let's see which ones go with which. Which numbers go with X and which number goes with Y. So if I look at X, X is IH. IH is listed first and second, and LM is listed first and second. So I know X goes with 15. So I can say 10 is to 6 as 15 is to X. Or I know since I'm going backwards, I could simply do 15 divided by my scale factor. It is the same thing either way. Karthik, what'd you get for X? What'd you get for HI? So HI, which is X, when you cross multiply, you get 9. We don't have units, so we don't need to worry about putting units. All right, and then for MN, MN goes with IJ because of the order in the similarity statement. So on that one, you could just do 7 times the scale factor, 7 times 5/3. Edriel, what'd you get? Okay, Y is 35/3. Is that what y'all got? Be so careful. 35/3 is a repeating decimal. It goes on forever. So on your quizzes, you would never put 11.6 repeating. That is not your answer. That is not exact enough for Miss Tanton. You do math, enter, enter. You convert it to a fraction. 35/3 is the answer. I do not want a mixed fraction. I want an improper fraction, please. Okay, said enough about that. Let's check your homework answers. This is 1 through 13. So 14 through 28, or sorry, 29. 15, please. Let's talk about number 2. See if I can zoom in. Sorry about this. We want to look at that picture a lot better. Okay, so on number 2, I was asked if that one could be angle, angle. So the thing is, yes, it could be angle, angle, but that is not the best answer. That is not the answer we would accept because you have to answer the question based off of the markings. You're going to answer the question based off of the markings. We have 2 sides marked and 1 angle marked. So you don't go past the markings unless you need to. This one you don't need to go past the markings. So you could make up numbers for these if you do not like to think abstractly. So you could say 2 is to 7 as 2 is to 7. Well, of course that's true. And so these are guilty of being similar by side, angle, side, similarity. Like I said, don't go any further and find extra things that you don't need if the answer is already there with the markings given. That's my answer about that, okay? What was the next one? All right, next one, 13. Oh, I'm pretty sure we did this on a warm-up. Guys, come on, didn't we do this on a warm-up? Okay. The length of a rectangle, here's the width. The length is 7 centimeters less than twice the width. If the ratio is 2 to 3, find the length and the width. Okay, so this is the ratio of the width to the length. Width to the length. Width to the length. And then you cross multiply, making sure you distribute 3x equals 4x minus 14. The answer is 14. All right, number 15, the ratio x squared minus 9 to x squared minus x minus 6 equals the ratio of 7 to 6. Find x. You have a couple of choices here. You could go ahead and cross multiply and then start solving. Or you could simplify that fraction, you could simplify it, and then cross multiply and then solve. Let me just remind you how to simplify it, okay? The numerator is called a difference of squares. You take the square root and you put plus or minus. That's how the numerator factors. The denominator, let's factor the denominator. 2 and 3, we want it to be negative, so we want the 3 to be negative and the 2 to be positive. So those cancel. So we've got x plus 3 over x plus 2 equals 7 over 6. And now we're just going to cross multiply. 7x plus 14 equals 6x plus 18. X equals 4. I hope I didn't do that too quickly. I hope I got the right answer. So in this one, factoring the numerator and the denominator and canceling out, or in other words, simplifying that side of the fraction really helped us solve for x. Number 16. Okay, this one is very important. You will see this one again and again and again. So everyone pay attention to 16 with me, because here's a mistake that students make. Are you ready? They say 7 is to 4 as x is to 21. Some of my students are going to do that on their test. Please take a look at that proportion and tell me what is wrong with that proportion. It is wrong. Good, good. Everyone's saying it. Very good. So please don't be the student that makes this mistake. 4 is a partial side. 4 is not a side of one of the triangles. It's a partial side. And so you need to find the whole side. You need to add 7 plus 4. The whole side is 11. 7, 11. 7 is to 11 as x is to 21. Then you look at solving for y, and you can say 7 is to 11 as 3 is to, don't you dare put y. You need the whole side. 3 plus 5. Or y plus 3. Now, some of you are going to tell me this. Some of you are going to tell me this. Are you ready? I'm not solving either of these. I'm just setting it up. Some of you are going to say, but I did 7 is to 4 as 3 is to y, and I got it right. I got the right answer. So, because in this one you're doing the whole side is to the part of a side, as the whole side is to the part of a side, because on that one you're being consistent, whole over part equals whole over part, on that one you're actually allowed to do it. 7 is to 4 as 3 is to y. This is actually true. But the problem we ran into our first one is that x is an entire side and 21 is an entire side. Neither x nor 21 are partials. So that's why it doesn't work when you use that one. I hope everyone understands the difference when you can use a partial and when you can't. If you choose to never ever ever use a partial side, you won't go wrong. So only use 7 is to 4 as 3 is to y if you know when you can use it and when you can't. Alright, so today's lesson is all about this figure that you have in front of you. Oh, we already know what it is because you probably looked at the calendar. So just things that you notice. You notice that D is a midpoint. D is a midpoint. We notice that. What else is a midpoint? E is a midpoint. But they're not necessarily dividing the triangle up in the same way. For all we know, this could be 3, this could be 3, and this could be 5, and this could be 5. So I'm not telling you that this triangle is isosceles, right? In fact, it's probably not isosceles, okay? So we notice that D and E are both midpoints. So we notice that this segment is connecting two midpoints. What do you think is true about triangle ADE and triangle ABC? You think they're similar? What are they guilty of being similar by? Side angle side similarity, very good. Because we have a shared angle right here. Angle A is congruent to angle A. That's the reflexive property, right? Okay. So if we were going to name a segment the midsegment, which one do you think we would name the midsegment? Yes, okay. Segment DE is the midsegment. A midsegment connects a midpoint to a midpoint. That's what a midsegment does, midpoint to midpoint. So go ahead and write that down in your notes, the definition of a midsegment. And just a reminder about notation here, the midsegment of this triangle is called DE. Capital D, capital E with a segment above. Midsegment. We're going to learn a few theorems about a midsegment, and then you'll start your quiz. Okay, so what happens, oh, by the way, triangles have three midsegments, right? Because they have three sides. So a triangle is going to have three midsegments, although sometimes we'll only look at one midsegment at a time. But what do you think is true if I draw all three midsegments of a triangle? I'm going to produce 4 triangles, and what do you think is going to be true? They're not all similar. Well, they are all similar, but they're more than that. All 4 of those triangles are actually congruent. 4 congruent triangles. It's really cool. A cool property about the midsegments. 1, 2, and then we're going to rotate this guy. They're not equilateral. I don't want you to get the fact that all 4 of those are congruent, but that doesn't mean they're equilateral, so be careful. It also works if the triangle is not equilateral. So I'm going to let you write this conjecture down, and then I'll show you a time where it works where the triangle is not equilateral. Oh, lag, sorry. The 3 midsegments of a triangle divide the triangle into 4 congruent triangles. Okay, I just wanted to show you that it also works, like I said, if our triangle is not equilateral. I wanted you to know that it doesn't just work in the perfect triangle that Miss Tanton drew the first time. 1, 2, see if I can grab it, 3, and 4. So no matter what type of triangle you have, when you draw all 3 midsegments, and if I were to rotate that perfectly, you would have 4 congruent triangles. It's really cool. All right, how do you think the length of the midsegment compares to the length of the base? So I'm saying that the midsegment in this picture is DE, and I'm calling the base of my triangle BC. They're more than just proportional. Half. You think DE is half of BC? Let's find out. So if I take this, do you see that? Oh, it's so tiny. There we go. And then I take another, oh, didn't mean to do that. We'll just put that over there. So if you notice, it takes 2 DEs to fill up BC. So that is our next theorem. A midsegment of a triangle, it's parallel to the third side and it's half the length of the third side. So it's parallel to the third side and it's half the length of the third side. Very important. Hopefully we got this down. All right, we're going to fly through these because y'all need to take your quiz. If AC is 20, then DE is 10 because the midsegment is half the base. If BE is 6, then BC is, well, double tick mark, double tick mark. So BC would be 12. If DE is x plus 6 and AC is 3x plus 4, then what is x? So we know that if we double the mid segment, we get the third side, or the base, depending on what you want to use. I'm going to let y'all solve that, or just solve it on your homework. I'm just showing you how to approach these problems. Solve for x. Okay, so here's where you were asking where to add the tick marks. So if this is 25, and this is half of this, the one that it's parallel to, that's the one that the mid-segment is half of. So if that segment is 25, then its base, each mid-segment has its own base. Its base would be 50. And so these are both 25 and 25. So someone was asking what kind of tick marks I could add to that. It would be a double tick mark because it matches those. So what did we do? We did 25 times 2. With mid-segments, you're either doubling or halving a lot. Okay? UA is 24, TN is 6, UT is 8. Find the perimeter of UPA. All right, well that's 24. We know this is 8, so this is 8. And then we just take 6 and we double it. And then you add up the sides of UPA. Okay, this is the last problem. Exactly one of the values x, y, or z can be determined. Find it. This problem is really important, so let's talk about it. We want to identify which points are actual midpoints. This one is an actual midpoint because 4 equals 4. This one is an actual midpoint because 5 equals 5. This one is not a midpoint because 2 doesn't equal 3. So you connect your midpoints, and now we know which one can be found. X is the only value that can be found. And what's the value of x? Well, it's half of 5. So x is 2.5. I hope that makes sense, which you can find one of the variables, only one of them, and then find it. So look at B. Midpoint, midpoint. This one is not a midpoint. So you connect midpoint to midpoint. So in this one, we can only find Z. We find the side that's parallel to. It's 10, and we take half of 10. So Z is 5.